Alright, welcome everybody. Here we go on this review. Sorry I'm posting it so late, but better late than never. Let's get through these problems. So factor each completely. If you're really struggling with this factor stuff, don't forget there's an entire extra factoring video online. Just go back a couple videos back when we started together back in September. Anyway, so the first one here is what's called monomial factoring. We have a monomial we're able to pull out. That is to say there's a 5 in front of both, and there's an a in both, so we may pull out a 5a. When I say pull out a 5a, I mean divide both by 5a. So originally we had a 5a squared, but we took 5 away, so there's no more number in front. And we took one of the a's away, so there's just an a left. And we took 5a away from 5a, which left nothing, but leaving nothing for multiplication is multiplying by 1. You can always double check by using the distributive property again. If I were to multiply back out, I would get back to where I started. Question number 2. We're going to go ahead and factor out a b. That is to say there was a b in both b cubed and 4b, so we took that b away. Again, if I distribute it to get back to square one. It's actually a two-part question. You're halfway there. You have to now recognize that b is something squared and 4 is something squared. Specifically, it is b squared minus 2 squared. Anything that's of the form a squared minus b squared, which is what this guy is, or x squared minus y squared. We did this as a difference of two squares. There's a nice little formula for us to have memorized. So in this case, we simply take that guy and turn it into a b minus 2, b plus 2. That is, we did square root, all done. On number 3, you have to recognize that there is a negative out in front, and in order to factor these quadratics, you have to factor out that negative in front. So we're going to take a negative away from every single term. This has the net effect of changing all the signs. So that negative became a positive, that positive became a negative, and that negative became a positive. After that, we have to ask ourselves which numbers multiply to 18. So we have 1 times 18, 2 times 9, 3 times 6. These are the only things that multiply up to 18. However, it multiplies to positive 18 and adds to negative 18, so both must be negative. And now we can hopefully see that negative 2 and negative 9 add to negative 11. Circle the answer and move on. Number 4. So number 4, it's tempting to immediately write the difference of two squares, and I probably wouldn't fault you. I'd probably only take off a point for it if you immediately went to an incorrect answer saying, oh, 4 is a perfect square, 36 is a perfect square, and I got 2v minus 6 and 2v plus 6. The problem is these can now have a 2 factored out, and this can have a 2 factored out. It's kind of just too much effort. What you should notice instead is both of these are divisible by 4. So since they're both divisible by 4, I can immediately divide by 4. And now we can do the difference of two squares. V minus 3 and V plus 3. Not too bad. Number 5. On question number 5, we have to recognize that there's an x I can pull out of all three of these. After that, we have to ask ourselves the numbers what multiply to 10. We got 1 times 10 and 2 times 5. They add to a negative number, so the larger number is negative. And that's it. X plus 2 times x minus 5. Just give me 1 second, I'm going to close the door. Hopefully it's not as loud now. Alright, finishing on up here, number 6. So number 6 is kind of like the more annoying question there is. This is one where you really want to have this on your cheat sheet somewhere to remind yourself how to do it. It's the factor by grouping or the squiggly line method. It's one of the longer questions. So first of all, we have to ask ourselves, what number are we able to pull out from all three of these? In this case, it's a -3 and a k. So to take a -3k out, we're left over with 4k squared minus 3k minus 10. And here comes that annoying part. Again, that's a -3k. I apologize for that terrible handwriting. That right there is a -3k. All right. The next thing we have to do now is we have to figure out what two numbers multiply to -40. So we did 4 multiplied by -10 to get -40. Now which numbers multiply to -40? Well, the numbers that multiply to -40 are going to be 1 times 40, 2 times 20, 4 times 10, 5 times 8. Nothing else works. And because they add to -3, the bigger number is a negative. And this guy right here is the one that actually adds to -3. So what we're going to do is rewrite that -3k as 5 plus -8. After that, we're going to go ahead and divide the problem into two parts. The squiggly line or just a vertical straight line is fine. When you do this, you have to ask yourself what number or letter or both is able to pull out of these first two. In this case, it's just a k. And then what number can come out of these two? There's a 2. The other rule is here, if this number is a negative number, you must pull out a negative out of it. So in this case, -2. And if you've done everything correctly up to this point, you get this 4k plus 5. That's the same in both. And if that's the case, I can pull out a 4k plus 5. And if I pulled out a 4k plus 5, what's left over is k minus 2. And we're all done. Now please note, if this method is so annoying to you that you can't handle doing it and you refuse to do it and you would rather do something else, I'm now going to show you an alternative method. So there is an alternative method to these problems. It's a little bit obnoxious, so you might hate this one just as much as you hated that one. But what we can do is the quadratic formula. So let's do the quadratic formula and let's do it on the calculator because this is not really required to show work if you're just trying to get the factored form down. So how you use the quadratic formula to factor. What we're going to do is we're going to go ahead and just do this part right here because we already know there's a -3k in front. And we're going to say that a equals 4 and b equals -3 and c equals -10. When I say the quadratic formula, hopefully we already have this memorized. If we don't, got to do so in the very near future here. B squared minus 4ac all over 2a there. Okay. Plug and chug, you know, just make it x equals negative of -3 over 2 times 4 plus or minus, got the square root, -3 squared minus 4 times -10, all divided by 2 times 4. All I did was replace all those guys, and let's use our calculator to replace those for us. So as a reminder, you are able to do a couple of things in the calculator. If you hit alpha, y equals, and then all the way down here, the enter button, alpha y equals enter, it will give us a fraction. So, or we could type this in and do a lot of this by hand. So we're doing negative of -3, which is just 3, over 2 times 4, which is 8. Let's see if I can turn the light on here. Is there a light? Oh, that's much better. Nice. All right, so 3 over 8. And then we need to do both plus and minus. We're going to do the plus one first. Plus. And now we need another fraction. Oops. Alpha y equals enter for that fraction. Square roots. And we got -3 squared. And then minus 4 times -10. All divided by 2 times 4 is 8. And hit enter. And one of the answers is 2. So in this case, we got x equals 2. It's actually k. No, I wrote x. It's actually k in this question. All right. Anyways, so we have k equals 2 as one of our answers, and then the other one, we just go back and we highlight this, and we change this plus sign to a minus sign. Took me long enough to get over there. And if we do it right, we'll get k equals -5/4. All right, so what do I do with this? How do I factor it and turn it into this? Well, it's actually pretty easy. All you have to do is make these things equal to 0. So what I mean is subtract 2 on both sides here, and that's going to give me k minus 2 equals 0. And if you notice, k minus 2 is part of the answer here, k minus 2. And likewise, I could, in this problem, multiply both sides by 4 to get 4k equals -5, and then add 5 to both sides. I get 4k plus 5 equals 0, and I get the same answers as up here. So you could use this method to get to the final answer as well. All right, let's go on to the next page. So the next page here is the discriminant. So let's just go through it really quick. So as a reminder of what the discriminant is. So the discriminant is always equal to b squared minus 4ac. It's the part of the quadratic formula that's under the square root. And there are 3 possibilities. D can be a positive number, D can be a negative number, or D can be equal to 0. And if D is a positive number, you get 2 solutions. If D is a negative number, you get 0 real and 2 imaginary. And if D is 0, you get 1 double. So what am I talking about here? Let's just go through this question right here. We actually really need to do one of them. It's really not too bad. So actually I did number 7 in class for some classes. So let's do a different one. Let's do I'm just deciding which one's the best bet. Are any of these having the negative answers, the bad answers that I don't like? 3, 6. I think 10. Let's do number 10. All right, so we're going to go ahead and move everything to one side of the equation first. So I'm going to go ahead and add 4a squared to both sides. By the way, you could have added a squared to the other side too. I'm just moving everything to the left. So plus 9a, and then plus 3 and plus 3. So overall I get 3a squared minus 6a. Just make sure I'm doing this right. Plus 3 equals 0. And now ask for us for the discriminant of this question. So the discriminant of this problem is going to be what? Well, we know a equals 3, b equals -6, and c equals 3. So we have b squared -6 squared minus 4 times 3 times 3. So we have -6 squared is 36. 4 times 3 is 12, times 3 again is 36, and we get 0, so we get d equals 0, and if d equals 0, then that immediately means that we have 1 double root, is how we write it. And you kind of just do the same thing for all these questions. I don't think I need to spend time doing it. You're literally just plugging in b squared minus 4ac, like we talked about at the top up here. If d is a positive number, you have 2 answers, 2 roots. If d is 0, you get 1 double root. We should have write root. And if d is negative, you get 0 real and 2 imaginary roots instead. Not too big a deal, so you don't have to do that much work. Solve each equation. When you see this, you have any option that you'd like. You can factor, you can complete the square, or you can quadratic formula. I'm just going to do whatever I feel like. What I feel like will likely be the easiest step. However, there are no requirements here. You get to the correct answer, I will be satisfied. You need to show at least 1 step of work. So if you can do it in your head, good for you. 1 step of work is needed. Let's subtract 12n first. When you get everything to one side, that'll be true no matter what method we're using. So we're going to subtract 12n, subtract 12n, subtract 8, subtract 8, and we're going to get 3n squared plus 8 equals 0. And at this step, couple options. It's actually easy enough on a problem like this to just subtract 8 on both sides, divide by 3, and take the square root. But just because I'm going to use the quadratic formula. There's no real reason for this, but I am. So A equals 3, B equals 0, C equals 8. And yeah, so we got negative 0 over 2 times 3 plus or minus the square root of 0 squared minus 4 times A times C, all divided by 2 times 3. So that's going to give me 0 plus or minus the square root of, well, okay. Now I got to do this in my calculator. So we got negative 4 times 3 times 8. It's negative 96. And then 2 times 3 is 6. And don't forget, if we have a negative under the square root, it needs to become an I on the outside. And therefore, we can finalize our answer. N is both 96 over 6 with an I and 96 over 6 negative with an I. And it's negative because it's both plus and minus. Please note that that is, again, not how it would be written on the SAT, etc., but it's fine for my class. So I'm just going to stop right there. If you want more help on how it could be written on the SAT or ACT or any other future test, please ask for help. It's really bad. All right, number 12. So number 12, and actually, you know what? I'm going to double check. I'm going to solve this another way, by the way. You could have easily done this. Subtracted 8 on both sides like I was talking about earlier. Divide both sides by 3. And take the square root. And put the I on the outside because of that negative. And then you'd have both positive 8 over 3 square rooted and both negative 8 over 3 square rooted. And this is the same thing as this. I really don't care which answer you put. They're both the same thing. Maybe as a fun little proof to yourself, you could prove they're the same thing. Anyways, r squared minus 57 plus 2r. So we're going to subtract 2r on both sides here. And we're going to subtract 7 on both sides here. And then we're going to get r squared minus 64 equals 0. And this one has a really cool thing that's nice. It's a difference of 2 squares. So we got r minus 8 times r plus 8. And therefore r equals 8 and negative 8. So easy. Could have also added 64, taken the square root, got the plus or minus. Lots of good options here. Number 13. So again, first step is always the same. You're just moving stuff to the other side, subtracting. I'm going to stop showing work on this because it's bugging me, but you are able to show as little or as much work as is needed. And then adding 8 is going to be negative, oh boy, 77 equals 0. So this question you could factor by grouping, you could use quadratic formula, you could do really whatever it is that you felt like doing. For me, I'm just going to do quadratic formula, hit enter on my calculator, and see what the answer is. So I got A equals 6, I got B equals 1, and I got C equals negative 77, and therefore K equals negative 1 over 2 times 6, which is 12, plus or minus the square root of 1 squared minus 4 times 6 times negative 77, all divided by 2 times 6. Oof. Alright, so let's use our calculator to go through this. So we want to make sure we got fractions all over the place when we need them. So we're going to go ahead and hit alpha, y equals, enter in the bottom right hand corner down here, and type it in just as it appears. I hope you could have seen that earlier when I was writing it. Oh well. We got, oh, that's not what I wanted to happen. So that happens sometimes. You can always highlight and copy if you need to. It's a good thing to make mistakes sometimes to show you guys that. So you got negative 1 over 2 times 6 is 12. Then we're going to do plus another fraction. We're just typing this bad boy in. Square root of 1 squared, which is 1, minus 4 times 6 times negative 77, all divided by 12. And if we hit enter on that, we get 7 over 2. And we get negative 11 over 3, obviously. Easy peasy. All right, let's do the next one. So, continuing on, we got 3 squared minus n. So 3 squared, and then we're going to add 9n to both sides, so plus 8n minus 18 equals 0. Just to switch it up, I'm going to go ahead and solve this one by factoring. Again, if you want to use quadratic formula, knock yourself out. You want to complete the square, you do you. It really just doesn't matter. Actually, you know what? I wonder if this gives me a square root answer. I need to make sure this is factorable. Negative 54, does anything multiply negative 54 and add to 8? I don't think so, actually. 6, 9. I don't think anything multiplies. I think this has to be quadratic formula. All right, let's just do quadratic formula then. So let's do quadratic. We got a equals 3, b equals 8, and c equals negative 18. And therefore, we got negative b over 2a plus or minus the square root of 8 squared minus 4 times a times c all over 2 times 3. All right, let's type this guy in. And I actually already know in advance what's going to happen. We're going to get a decimal answer, which means that we can't really use the calculator the whole way through. That's okay. So let's do alpha y equals enter negative 8 over 6 plus alpha y equals enter, we got a square root of 8 squared minus 4 times 3 times negative 18 all divided by 6. And sure enough, like I said, we get this decimal answer, which means that we can't only use a calculator here. We actually have to do some simplification on our own. So let's just do just the negative 8 over 6 part. And we can do delete, 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 delete. Oh. I wanted that 6 there. I'm just deleting everything. Just so I can type in just negative 8 over 6. Probably would have been faster to retype it. You get negative 4 over 3. It reduces for you. Of course, you could just divide them both by 2. And this part, we kind of just need to do the square root part in our calculator. So we're going to do just the 8 squared minus 4 times 3 times negative 18. It's going to be plus or minus 280 square rooted. Like that. And you just write our two separate answers like that. We have x equals negative 4 over 3 plus the square root of 280 over 6. And x equals negative 4 over 3 minus the square root of 280 over 6. And that's the whole problem. Easy enough. Mostly calculator work. Let's move on to this next one. Let's go ahead, add 8 to both sides. Add 4x to both sides. Can't do math right now. Negative 6 equals 0. Here's a nice little trick for a question like this. If all 3 terms are negative, if all 3 terms are negative, they're not negative, geez. All right, if all 3 terms are divisible by 2, we get x squared plus 2x minus 3 equals 0. I just divided them all by 2. If I divide all of them by 2, it makes our life a lot easier. And actually now we can do a nice simple problem. What multiplies to negative 3 and adds to positive 2? Well, that's going to be positive 3, negative 1. So x equals negative 3 and 1. Easy peasy. Finishing this off, we only have one problem left, thank goodness. Now we got 3n squared minus 10n plus 9. Oop, not plus 9. My brain got ahead of itself. Equals 0. And now, does anything multiply to 9 and add to negative 10? It actually does. This one I can actually factor by grouping. Again, if you want to use quadratic formula again, knock yourself out. I think this is actually faster if you get good at it. So 3 times 3 is 9, and it turns out that 1 times 9 and 3 times 3 is 9. And if I'd made both of these negative, they'll add to negative 10. So I can rewrite this as negative 1n minus 9n plus 3 equals 0. Factor out an n. Factor out a negative 3. and I get 3n minus 1 multiplied by n minus 3 equals 0, and therefore 3n minus 1 equals 0, n minus 3 equals 0, 3n equals 1, n equals a third, and n equals 3. Again, quadratic formula if you want. Complete the square. I don't really care which method you use. Pick your favorite. Get it right. Use a calculator. Have fun. Let's start graphing these. So, graphing these equations. So, I'm not going to spend too much time doing every single little question, but I will go in depth into these first two and number 20. On the actual test, there's exactly one graphing question. The key here is, especially if right now you're spending your time making up a cheat sheet, what I would like for sure on every single one of these are a couple of things. As a reminder, number 1, I want the y-intercepts. Number 2, I want the x-intercepts. Number 3, by the way, there can be multiple of these, or 0. Number 3, I want the axis of symmetry, which is always x equals negative b over 2a. And this one, by the way, is always x equals 0, and this one over here is y equals 0. And number 4, I want the vertex, which is negative b over 2a comma something. You got to plug that negative b over 2a in. However, on some questions, it's kind of it's not too hard just to play connect the dots on things. So like, let's just do the first one. For instance, the y-intercept on this question, it says x equals 0. Well, if I make x equals 0 here, well, that means that y equals 0. So I have the coordinate 0, 0. Which is also the x-intercept in this question. So this is right here is the x-intercept and the y-intercept. So this is the x-intercept is the y-intercepts, and that's it. It's both of them. The axis of symmetry, it's also the axis of symmetry because it's the vertex as well. Because if I did negative b over 2a, there is no b up in this question. So it is also this axis of symmetry going up and down, and the vertex. So how am I supposed to get some other points? All you have to do, start plugging into your calculator. How do you plug into your calculator intelligently? So I could take the time of doing like 2 times and like 1 and the parentheses squared and then, typing this all in, but there's an easier way. Go to your y equals screen. I have no idea what this is all about. Let's clear that off. All right, over here, we're gonna go ahead and graph 2x squared and hit graph. I have no idea why the window's so messed up, but you can always fix the window by hitting zoom and then number 6. All right, here's our cute little graph that we got there. And we can go ahead and say, hit trace. And if I hit the trace button, which is right there, and then something like the number 1, it'll plug it in and it will tell me that I have the coordinate 1, 2. So I got the coordinate 1, 2. And likewise, I could plug in negative 1. That will also give me 2. And I can plug in 2, and that'll give me 8. 6. Oh, there's an 8 right there. How do I not notice that? What did I just do there? I used the mirror image idea. Just graph it up. Okay, so that one was kind of a freebie. Not really too difficult. Let's move on to a more difficult problem like number 18. So number 18, to start off, our y-intercepts. Our y-intercept, again, is when x equals 0. So in this question, it's y equals 0 squared plus 2 times 0 minus 3, or y equals negative 3. So we got the coordinate 0, negative 3. Again, it's always whatever it is on the outside over here. Okay, that's our first coordinate. After that, we can figure out some more coordinates. To figure out some more coordinates, we're going to find our x-intercept, and our x-intercept is what happens when y equals 0. So we're going to have 0 equals x squared plus 2x minus 3. We've just been solving these a whole boatload on the previous pages, so hopefully we're good at solving these by now. And I think actually this exact question was on the previous page. Look at that. 2x minus 3 right there. So we just factor it again. So we got x plus 3, x minus 1. So we got x equals negative 3 and positive 1. So in other words, we got the coordinate negative 3 comma 0 and 1 comma 0. Let's put those on our graph. Okay. After that, we need to find our axis of symmetry. As a reminder, what I said earlier, we could do x equals negative b over 2a. So we have negative b over 2 times a, which is negative 2 over 2, which is negative 1. So we have x equals negative 1 as our axis of symmetry. Please note, you didn't have to do it that way. You could have easily remembered that all you had to do was add the two x-intercepts together and divide by 2, and that would also give you negative 2 over 2 or negative 1, because you're the same exact answer. You pick your favorite. Anyways, so you get the negative 1. So to find the vertex, we plug negative 1 into the equation. We get negative 1 comma something, negative 1 comma what? Let's use our calculator to figure that out. X squared plus 2x minus 3. Hit that graph button. And now we just need to plug in negative 1 for us. So we're going to hit trace, plug in negative 1. And we got that negative 1 comma negative 4 there. And like I was saying earlier, there are a couple things I wanted, and I don't know why I didn't write it here. I did it. I found my 5 coordinates. Over here, there's a 5th thing that I want here. Every graph, I want 5 coordinates. That's a minimum. You can put more if you want. So right now I have 1, 2, 3, 4 coordinates. Let's go ahead and put those all in the graph. I got negative 1, comma negative 4. There's my vertex and my axis of symmetry. Using a mirror image idea, where's the other one got to go? It's got to go right there. If you didn't believe it, you could also just plug negative 2 into your calculator, using that trace button again. You get negative 3. Play connect the dots. Alright, cool. Let's do another one. I was going to say do number 20, but I think I did that one in class. I wonder if there's one. What I want to do. No, I'll do number 20. Alright, so let's do number 20. If I have my y-intercepts, I'm going to do it faster this time. I got 0, 8. Y, I plugged in 0 and I got 8. Number 2, my x-intercept. If I make y equals 0, I'm going to have to use my quadratic formula for this guy. We're going to have a equals 1, b equals 7, and c equals 8. If that's the case, a is 1, b is 7, c is 8. Quadratic formula, negative b over 2a, 2 times 1, plus or minus square root of b squared. 4 times a times c, all over 2a, 2 again. This is not actually a pretty number. If I do the math either on my calculator or somewhere else, 7 squared is 49, 4 times 8 is 32, and 49 minus 32 is 17. I get this nasty answer, which means that my x-intercepts are negative 7 over 2 plus the square root of 17 over 2, comma 0, and negative 7 over 2 minus the square root of 17 over 2, comma 0, which is useless. We can't actually graph these. There's no real reasonable way of doing it. I mean, we could plug them into our calculator to estimate, so these are not going to be coordinates we put down. We need to have them written somewhere on our paper to note where they are, but we're going to go ahead and move on to number 3, the axis of symmetry. Because the axis of symmetry is nice and easy, it is always negative b over 2a, in this case negative 7 over 2. It's the same thing, whatever is over here when we plugged in our quadratic formula. It's this guy in front, the negative b over 2a. So it's just x equals this guy. Which means that our vertex here, negative 7 over 2, comma, go to our calculator again and start plugging it in. So you got y equals x squared. Uh-oh, I didn't delete everything. Jeez. X squared plus 7x plus 8. Alright. So we graph that guy in there, and we hit graph, and we hit trace. negative 7 divided by 2, and we're going to get negative 4.25. So let's go ahead and rewrite this as a decimal, negative 3.5 comma negative 4.25. Easy enough. But number 5, we need some more coordinates. Well, let's just use our calculator to find some more coordinates for us. Let's plug in 2. Why? I don't know. Oh, 26. That's too big a number. I can't graph 26. How about I plug in negative 2 then? Ooh, negative 2 comma negative 2. Nice. How about negative 1? Oh, positive 2. Nice. How many coordinates do I have now? I got 1, 2, 3, 4. Not quite enough yet. How about negative 5? I don't know. I got negative 2 again. Ooh, how could I have figured that negative 2 out? Well, it's the same distance away from the axis of symmetry. Could use that mirror image concept. Let's put these on though. 0, 8. Okay, that's way over yonder off the page. There you go. Way up there somewhere. And then you got negative 3.5 comma negative 4.25. So 3.5, 4.25, right there. You got negative 2 comma negative 2. You got negative 1 comma positive 2. That's also off the page. Maybe it's even further up there then, right? And then negative 5 comma negative 2. Another one that's off the page. So that one's off the page. You probably need one more that actually is on the page. Let's see. One that would be... Did I mess... Oh, negative 5, negative 2. Oh my gosh, that's right there. That's a mirror image one. So this one's like over here. So we actually need 2 more, don't we? So we could really actually get this on our graph. Why don't we plug in negative 3? See what we actually get. Negative 3. And then negative 3, negative 4. So that's negative 3, negative 4. Mirror image idea, it's got to be right there. Now we can finally play connect the dots. Please note on the test I made the graph absolutely massive, so you will be able to connect the dots nice and easily on this one. Anyways, that is the end of the video. Good luck on that test tomorrow, guys. Or the next day, depending on when you got it. I also want to say, if you need more time on the test, to take the test, you need to take it on a different day or something, please just let me know in advance. That way we can find a date and time that is appropriate. Have a wonderful rest of your day, and see you later.